Oops, I'm off to a great start here. Okay, like clients, we've had the peer-to-peer protocol changes out there for a while now. We had made a release with them. Hector has implemented MWEB like client support and Electrum and Light Wallet and others, and he's helped Cake Wallet, and so there's a few beta, alpha, whatever stage testing like clients out there using the new messages. Everything seems to be working, so we're moving towards adoption there. And also Hector has been working on hardware wallets, in particular Ledger. He has an implementation ready for Ledger that supports peg in, peg out, the whole works for MWEB, and it looks pretty good. So we're going to be getting that audited here. We're going to start that process soon. And then once that happens, then we should be able to get that merged into Ledger's repo so that we can get the app actually shipped to everyone. So everyone can start using MWEB from Ledger, which would be pretty cool. But also we have PSBT. PSBT is like partially signed transactions. It's just a format for that hardware wallets and other things use for like sharing partial unfinished transactions that they can use to like sign them offline or whatever. But that's just something we've been working on for V24, but it turned out we didn't actually need that in order to support it on Ledger, so that was cool. But we do have we do have that included in version 24, along with the scripter wallets, view keys, a lot better stability. The last release has some issues with the wallet for MWEB transactions, especially around restoring, and I've been working pretty hard at trying to like get all those ironed out. So, long story short, should be much more stable release, have some cool features, but yeah, it seems like it's been forever. It really has. So where is V24? Well, it's getting towards the end. I'm doing all my local testing now. Just like everything's implemented. I'm just testing locally, finding different bugs, trying to make sure that all the different scenarios are covered. But we should be able to move on to code review and community testing very shortly. So getting towards the end, should start to see V24 moving fast now. Let's hope. Been saying that forever now, but I mean it this time. All right, that's it for the dev update. Now, I'm going to talk some about privacy. So obviously, MWEB is a privacy layer that I've talked a lot about, obviously, for the last few years. But I want to talk about like the different ways you can leak privacy when using a blockchain, and the ways we circumvent it, what MWEB covers, what it doesn't cover. And then I'm going to talk about our next big improvement to improve privacy even farther, especially well, I'll just get into it. We'll just go one by one here. So we have network origin. So if you think about how like the Litecoin network works, so you just have a bunch of peers connecting to each other. As one creates a transaction, they just tell their neighboring peers about it, and then it's just a very gossipy protocol. Like everybody tells everyone else, make sure that everyone has seen every transaction, every block. And so the problem with that is that if you have like a heavily connected node, say, this big brother down here in the bottom left. So if it's connected to everything, and then Alice here decides to broadcast her transaction to all of her connected peers, well, he's going to see the transaction come from her first, and then all of his other peers will send it to him secondhand when they see it. But he's going to know right away that it's Alice that created the transaction. He's going to know the address it came from. And so we now have a direct link from transaction to IP address, network address, like the physical location, basically. So that's one of the big ways that you can leak privacy when you're transacting on Litecoin, but there's some obvious solutions to that. So you've got Tor, I2P, both of those are supported in the latest Litecoin release. You can use either of those networks for obscuring your IP, obscuring your physical address when transacting, so that no one knows that you are the one creating a transaction. No one knows you're the one sending money. And then there's also on the right here, there's this Dandelion thing, which we could get into another time. That's another option we have in the future that doesn't require running some heavy mix layer on top of Litecoin. But for now, we have some very, very good solutions for this. Just like Bitcoin, they have Tor and I2P support. So that's one way you can leak your privacy when transacting, but we have a very clear solution for that one. But then another one is transparent amounts, right? So Bitcoin, if you think about how it works, or basic Litecoin transactions, you have inputs, outputs. You have Alice's wallet may have 500 Litecoin in it, as you see here. She wants to send just a little bit to Bob, maybe for a coffee or something. She sends 0.2 Litecoin, and she has to send the change back to herself, 499.8 Litecoin. All of a sudden, Bob knows Alice has a lot of Litecoin. So that's, if you had to use your bank, if you had to show how much was in your bank account every time you transacted, would be embarrassing for me. But for some of you, it'd just be it'd be a little concerning because suddenly a threat of someone trying to rob you or whatever else. It's just not very safe. We obviously don't want to share that information with each and every person we transact with. So MWEB, of course, as we talked about in the past, helps with that. So amounts are all hidden perfectly, with the tiny caveat of if you're doing a lot of pegging in and pegging out, you can screw stuff up there. But for the most part, amounts perfectly hidden. You don't have to worry about anything leaking there. So that's another way you leak privacy when transacting, but the MWEB solves that one very nicely. So then a third one is address reuse. So if you if Alice wants to receive Litecoin, she may post her address on Twitter or whatever and say, hey, send me some Litecoin here. And a couple of people may send her some. She may then spend those Litecoins to Bob, send the change back to herself. And then later she may receive more Litecoins in that address. And then when she spends those, maybe to Carol, and then she gets the change back. But everybody knows that each and every transaction involving that address in perpetuity is Alice. So, like every time more funds go to or from there, you can link that entire transaction directly to Alice. MWEB solves that very nicely as well. We use stealth addresses, where this is all you'll end up seeing on the blockchain is just some unique private key that doesn't ever get reused, or some unique public key doesn't ever get reused. It's just perfectly hidden. You don't have any idea who it is. You learn very, very little about the transaction. So that's another way you leak privacy, and MWEB perfectly solves that one too. And then the last way you can really leak privacy is through transaction linking. This is, 1 second here, sorry. Screw up. Okay, so this is, if you, I don't know if this diagram even makes sense, but assume these are each different transactions on the left here. So Alice is transacting, she's sending to Bob, then she's also sending to Carol, and she has fresh change addresses for each transaction. Like when she goes and spends later, well, we see like originally like the address reuse, like we talked about, and there can be more complicated scenarios where you don't reuse addresses and you still end up with a very simple diagram like this. But even though she's using separate change addresses, if she then spends those change together, then everybody knows that change was hers. They can go back to the original transaction. They can see that Bob received, well, they can see that which of the two outputs from her from each of their transactions was her change. So she's leaking a lot about her transaction here. But more importantly, we have Chainalysis and governments and other big adversaries that are looking for all kinds of different links in the chain. Like I show on the right here what the whole diagram looks like if she spends her change together and sends to me. You can see on the right, like there's different links you can find on the blockchain as things like Chainalysis gets access to exchange data and just any other centralized custodian, and just generally gathers information about the different parties on the network. They can really piece together and make connections that maybe you or I can't just by looking at the blockchain. And they can learn quite a bit about where money moves, who is moving it. You end up leaking quite a bit of data there. And MWEB does not actually, MWEB does not actually solve this perfectly. We do have coin joins that take place after the transactions are shared. But in order to actually join the different transactions together and to kind of mingle them all together, you still have to broadcast your original transaction to everybody on the network. Everybody has to see your transaction before it's like combined into the big, like merged mess at the end. So this is one area where the privacy is just not very strong for MWEB, but there are solutions for it. And I've started working now on at least the design for what I think is going to be our next big thing, which is coin swaps. So years ago, John Trump, he's an engineer, mathematician for Brin. He came up with this protocol for swapping out your coins for fresh ones, like with cleaner histories and kind of obscuring ownership of coins. So if we think about how like a transaction works, say on the left here we have Alice, she's sending to Bob. We have this red circled output. So even though nobody else on the network, unless she tells them, knows that belongs to Bob, and no one else will see the amount, she knows that she sent that to Bob, and she could tell whoever. And she can watch the blockchain to see then later when Bob spends that coin. She'll see a transaction that goes out, and she'll see it as soon as he spends it, and she'll be able to follow that. If it's like a central custodian that does that, they'll have access to even more data, and they may learn even more about they may know who Bob then is transacting with based on their database of coins that they know about and transactions they know about. What CoinSwap does is once you receive a new coin, once you receive coins from someone, say, in this case, Bob receives from Alice, instead of then directly sending those, later, having them sit in the blockchain and having Alice being able to monitor them, you can actually just swap them out for fresh coins. You send kind of like this, the current coin. See, I don't know if you can see that really well, but the current coin, and then a new coin you want, you send it to this kind of mixing service. They get a whole bunch of messages like that, and every so often they will combine them all together and post a transaction to the blockchain. So you see then this is the big transaction they create. Alice knows that she sent this red output here, this red coin, and she'll see this new transaction to see that the red coin is spent. But she'll also see that a lot of other coins are included in there too. And she'll probably know it's a coin swap transaction, but she won't know which coin Bob gets back in exchange. So it's just a big mixing service that lets you it just lets you hide ownership, in particular from the person who sent it to you, but from others as well. It really increases the anonymity set. So you just have this central server that you just send your transactions or send your outputs to, and they give you new ones, which is really cool. But there is a problem here, right? So if this, let's see, that's Big Brother here is our mixer. It's an obvious single point of failure for privacy. If that server just logs everything that happens, then if they turn out to be a bad actor, then you end up even worse off than the situation before. But the CoinSwap protocol is kind of fancy, so you can you can split those up instead of just saying, "Here's my coin, give me this new one instead," which is the same value. You can kind of split that message up and give a little bit to a number of different CoinSwap servers. And then each of those CoinSwap servers have to work together to build the final CoinSwap transaction that you see on the right here. And as long as at least one of these servers is honest, then none of them can know the link from your original coin to the green one you receive over here. So if you would have maybe trusted community members, each running their own server, and as long as one of them is not working with the feds or whoever else, then you know that your data is safe. You only need one honest party. So it's a huge improvement over like the existing CoinJoin protocols where you have to really trust the centralized custodian, the centralized mixer anyways. And instead you can kind of distribute that trust, and you only need to trust one out of N different CoinSwap servers. And it uses, I have it shown here as like communicating with each one. It's a little more complicated than that. It actually just creates a big onion packet similar to how Tor works, but we don't need to go into the details here. I don't even know how much time I have left, but the cool thing is that Grin has this working fine on their network. There's this second link here shows a repo with a working version of this CoinSwap service, and we can very easily adapt it for us. We have the non-interactive transactions, the ability to just send to an address instead of having to like communicate online with your receiver in the complicated way that the original MWEB works. Ours is very simple, but we added like a lot more complexity to our transactions as a result. But I've been working through it all, and we're able to very simply adapt what they have and still use, and not have to do anything crazy extra to make it work with non-interactive transactions. So this is something we can get going in the very near future if we get the infrastructure set up, the different parties to host a service. And then wallets, the way where they would work is they would just you could just configure it to automatically swap any new coins you receive. And it doesn't completely solve the linkability thing, but it makes it so much exponentially harder for everyone else to learn, especially even Chainalysis, for everyone to learn about what's taking place on the network, to kind of find those different links I talked about earlier, those different patterns in the network. When your anonymity set is growing all the time, it starts to work a lot more like Monero does, or a lot more like Zcash does. Theirs is a little farther still, but it takes an even larger step in that direction compared to the core Mimblewimble that we have now. So that's what I'm going to be working on as soon as we get V24 out. And I'd be happy to do a write-up too on this on the forum, so that people who are interested in the details can really dig into it. But yeah, I think that's all. So any questions for me? I don't know. Is there a way to relay them? I don't even know how much time I have. Looks like I have no time left, so I can't hear anyone. I'll assume there's no questions, but If there are, just tell Rebecca or something, and I will answer them for you. 1 second, she's typing.